All right, ready to go? Thanks everyone for joining. Today I'm going to talk about creating custom maps in Einstein Analytics. I'm Corey Hammer. I'm a technical architect at Formize. And let's see if the clicker, there we go. Technical architect at Formize. Before I joined Formize, I was a technical architect at Salesforce Services for 5 years. Formize is a platinum partner in the financial services industry. And of course, the forward-looking statement. There's nothing that I'm going to show you today that's not already available on the platform, but as always, make your purchasing decisions based on what is currently available. All right, so sneak peek. This is what I'm going to demo today, how to create a chart that looks like this in Einstein Analytics. We're going to be using the custom map feature to visualize our data in a diagram that resembles the structure of a building. And of course, this is the Salesforce Tower. So I'm going to give a quick overview of Einstein Analytics. How many of you are already using Einstein Analytics today? Most of you, okay. So we maybe don't need to spend a whole lot of time on that. I'll give a quick example on using the trailhead example of zip codes to show the custom map on a geographical map. And then we'll go through the Geo JSON format, how to plot coordinates, create your own Geo JSON file, validate it, and I'll show you how to create a simple skyscraper. And then we'll go through a couple cool examples, Salesforce Tower, Empire State Building. All right, so for anyone that might not be familiar with Einstein Analytics already, of course, it's a powerful reporting platform available from Salesforce, in addition to what you might use as a standard reporting functionality. It's an additional license for additional features. It has built-in support for external data sources from Heroku, Postgres, Azure SQL, Amazon RDS, and it uses its own data storage space. You can have up to 200 million records with the growth license, up to 1 billion with the plus license. So the big benefit here, of course, is you're not using up all your Salesforce org storage space just to be able to do some analytics. Even if you're pulling in data from your Salesforce org, you still have to create a data set to sync that data in from your Salesforce org. So then you create data sets. You can do translations with recipes, data flows, explore those with lenses, create dashboards, use the SOQL query language to create queries. It's different than SOQL if you're familiar with SOQL, and we'll create those dashboards. These are all the external data connectors that are available built into Einstein Analytics. If you're not already familiar, lots of different options to pull in your data from external data sources. All right, so maps in Einstein Analytics. So here you can see using a map of the world to project your data onto a visualization of the world. So it's a different chart type. Instead of a line chart, a bar chart, you can use a map. You can put your data into countries. You can overlay that map with a custom map of your own. And then usually what you'll see are the gradients for the different colors that show the volume of the data that you're showing on your map. And there's a really great Salesforce blog that talks about this and shows some examples of what you can do. Definitely recommend checking that out if you're interested. So there is a trailhead, and I'll give you the link later in the presentation. But this trailhead walks you through creating a custom map using zip codes. So this map is a map of the LA area. All the white squigglies are zip codes. So the default map in Einstein Analytics doesn't give you all that. It just gives you a map of the land area. And the zip codes are defined with Geo JSON. It's laid over on top of the map. So what defines a map in analytics? Well, it can be any set of polygons. It's not just limited to physical maps. And it uses a Geo JSON format to define those maps, any set of XY coordinates. And then you can show your data on geographical maps, some examples, counties, zip codes, voting districts, or you can make a shape of any shape you want with XY coordinates and polygons to show that visualization. So this is the Geo JSON format. This is how you define a custom map in Einstein Analytics. It is actually a standard. It is a JSON format. It's just an extension of the JSON format with some specific attributes that are used to define coordinates for your custom map. What I'm showing right here are kind of the bare minimum parameters that you need for your GeoJSON file. The GeoJSON format supports a lot more than this, but for the purposes of a custom map in Einstein Analytics, these are the core things that you need. In particular, the one thing that is important to note is you need to be able to map your data to the objects that you're going to draw with your coordinates. And in here, you see there's an ID field, and that's what is going to be the key for that data to put it into this polygon. So how do you create a GeoJSON file? Well, you can do a couple different mechanisms. You could take a sheet of graph paper and you could use that to either print onto it or trace it, and you can use that as a guideline to figure out what your coordinates need to be. Or you could use a image editor on your PC and get your pixel coordinates, use that for your coordinates. And one way of doing that is with an image editing tool such as the GIMP, the free tool, maybe Photoshop. And even on your operating system, you can, on a Macintosh, you can do a Control-Option-4, and it gives you a way to crop on the screen. It'll show you coordinates if you do that. Not sure if it'll show. If I do that on my screen now, it's not showing it. But the important thing to note is if you do that, the 0, 0 coordinate on your screen is typically the top right coordinate. The 0, 0 coordinate on a custom map in Einstein Analytics is the bottom left coordinate. So you would have to transpose it. You could actually just use the negative value for your coordinates, and it would fix that for you. Then once you have your coordinates, you want to validate this file using any JSON validation tool, such as JSON-lint. If anyone's done JavaScript development, has worked with JSON files in the past, you've probably used this tool. You can use the same tool to validate your GeoJSON file. There's also another site, GeoJSON-lint, that actually validates the specific features for GeoJSON. So once you have your GeoJSON file, you want to test it in Einstein Analytics. So before you can load into Einstein Analytics, you have to have your data, because it all starts with data. There's no other reason to have a chart in Einstein Analytics unless you have some data that you want to represent. So create your data set, and then you upload your GeoJSON, and you can either explore it with a lens or create a dashboard. We'll set the chart type to map, we'll import our GeoJSON, select the fields that we want to use for the locations and the colors. I'm going to show you all this in a second. So knowing that the custom map can be any shape that you can represent with polygons, we can do something like represent a skyscraper in Einstein Analytics. Now, if you think about a skyscraper in its simplest form, it's just one big rectangle, and each floor is a smaller rectangle within it. So we can plot out some coordinates for those floors and make a representation that looks like a skyscraper. So when we look at each floor, again, it's just a polygon with XY coordinates. So, and you want to have your coordinates in the right order so it draws a shape. You don't want to have perhaps the third and fourth coordinate flipped because you might end up with something that looks like a bow tie. But you can start in the top left, go to the bottom left, the bottom right, and the top right. And then Einstein Analytics will complete that polygon from the last coordinate to the first coordinate for you. So in this example here, you can see the line that we'll have to put into our Geo JSON file to represent this polygon shape using the coordinates for the XY. 20 pixels high in this case for the top left, so or 0, 20, 0, 0 at the bottom, 100 pixels over to the right for the Y coordinate for the bottom right, so 100, 0, and then back up another 20 pixels, so we have a coordinate of 120. All right, so let me do a demo where I show creating one of these. And the tool I'm going to use to create this is actually a spreadsheet. So let me see if this looks big enough. Is that big enough for everyone, or should I zoom in a little bit more? Zoom in. Better? All right. So what I have here is a spreadsheet, and I have each coordinate in a cell in the spreadsheet, right? So the top two columns, or the first two columns here I have are the top left coordinate, the X and the Y, bottom left X and Y, top right X and Y, bottom right X and Y. And then I put them all together here for the coordinate string. Now I have some formulas in here that make this a lot easier for me. If you notice, if I click in here, you can see that I'm just taking all those coordinates, putting them together in a string with the brackets and the commas that I need to for the GeoJSON format. And it's going to put all these coordinates into a string for me. Also, each of these cells is a formula, so they all relate to each other. So in that previous example, we saw the top left coordinate was 20 pixels high, so I could just put in 20. And you can see with the formulas are starting to kick in and fill in the rest of it. The top right coordinate is its X coordinate is 100 pixels over, so I put in 100. And that was all I had to put in because the formulas take care of the rest. Because if you think about it, your two left coordinates have the same X value as well as your top and bottom left coordinates have for the X value. And the height for the left and the right is going to be the same. So from all these formulas, it's able to populate all that for me. So the second row is even more driven by formulas because for the second floor, I want the bottom Y coordinate to be the same as the top Y coordinate for the first floor. So using that, the formulas fill that in for me. So the bottom left Y has to be 20 to match. So it puts it all together. That second floor is in for me already. So now I can just make this I can make this skyscraper as tall as I want now. Just copy and paste, right? So there's row 3, floor 3, floor 4, floor 5, floor 6, 7. We'll take it up to 10. We'll make it a 10-story building. Okay, so now we have 10 floors, and as you can see, we have the XY coordinates for each of those floors in this column of the spreadsheet for me. So now the next step is to take this and put it into the rest of the GeoJSON format. And I do have another table here, another tab here, which, let me clear these out and start over. And I'll zoom in a little bit more. Okay. So here's taking those coordinates from the first tab of my spreadsheet that I had on that far left column, and it's adding in the other attributes that I need for the Geo JSON. So here you can see I have 2 floors already in here. And if I open this up, it is very small, I'm sorry about that. But as you can see, another formula is taking the coordinate string from the other page, putting it into, from the other tab, putting it into the cell, along with some of the other string formatting that we need. And, oops, undo that. So now, likewise, I just need to, again, copy and paste this. Oops. And then again, take it to the 10th floor. Now you can see in each of these rows that I'm pasting in here, it's incrementing that ID value that I was talking about before. That's what's going to map my data to this polygon. And you can see that the polygon coordinates are coming in from the other tab. So this is floor 9. We need one more, floor 10. Awesome. All right. Now we need to get it out of a spreadsheet into a text file. So the way I do that is I export this to CSV. So I'm going to export this to a file. And let me go to Finder and go to okay, so when I exported this, what Numbers did for me is it created each of those tabs as a separate CSV. So you can see I have Table 1, Table 2. Table 1 I don't really need anymore. That was just the original sheet. What I really need is just the tab from tab 2 in the file that it created. So I'm just going to rename this file. I'm going to call it a .json file, even though it's not yet JSON. I'm going to fix it. I'm going to take this file and open it in a text editor. I'm going to use Visual Studio Code. You could use any text editor of your choice. Now you can see there's some things I got to fix in here, right? There's some artifacts out of the export from the spreadsheet. So I'm going to go in here and clean this up a little bit. So I'm just going to take out some of these double quotes. Oops, sorry. Screen's a little bit smaller than I'm used to working with here. Take those out. Take out these extra double quotes. Things are starting to get colored correctly to give us a sign that they are looking a little bit more valid as JSON. And one more. Okay, so this is looking better now on each line. Now there is a little bit I have to put on the top of the bottom here. I'm going to grab this from another file that I have. All right, so everything's looking good so far. We have what I hope is a valid JSON file. Now I want to validate this file to make sure that it's correct. So I'm going to go to JSON lint. And I'll just copy this, paste it into JSON lint, tell it to validate it. Valid JSON, awesome. It's a good sign. Obviously, if I had something wrong in here, say I was missing a bracket or something, it would tell me there's an error and what the issue is. But that's good. Now let's take it a step further. Let's go to Geo JSON lint, and it's going to do something similar. Now it's assuming that I'm going to be trying to put in Latin long and plot on a map, so that's why the map is showing there. I actually don't need it to do that, but that's okay. I don't need to worry about that. I'm going to paste in that same JSON content. Now you're seeing here that it is telling me that I have some errors in my GeoJSON. What it's saying here is that my end coordinate is not equal to the very first coordinate. But in Einstein Analytics, I actually don't have to worry about that because Einstein Analytics is going to automatically complete the polygon for me. I don't have to put that in. So I'm not going to worry about that error. But if I were to take something else out of here, say I took out type feature. Here you can see that it's telling me that the GeoJSON feature must have a type equals feature member. So this is a tool you can use to validate your GeoJSON. So we have good GeoJSON now. So now let's go into Einstein Analytics and start testing this out. As I mentioned before, the first thing you have to have is data though. So let me show you the data file really quick that I'm going to be using. And let me blow that up a little bit. So this is a sample data file. I've got some floors, I've got some suites, I've got some generic tenants in here, I have some vacant suites, and I have some attributes like the expiration date, the square footage of the suite, and the year it expires. So I'll be able to show this data now in this GeoJSON custom map. So let me switch into Salesforce and go into, log back in first. And then I'll open the app launcher and I'm going to go to Analytics Studio. So the first thing you would want to do is you'd want to import that test data. Go into Data Manager, click on Data, and click the Create Dataset button, and just take the CSV file and just drag it into here. And it's going to show you a few attributes about the file. And then it tries to do some automatic detection of the data that you've put in there. You can see that some of these is showing as dimensions with the A icon there. That means they're text strings. And some other things have this tape measure icon. Those are dimensions, which are numeric. We have some dates in here as well. But it looks like everything is coming out the way I want. So this is good for my test file. I can just click Upload File. I already have this one uploaded as tenant data, so I'm going to use that. So good, we have data now. So now we want to go ahead and create a dashboard. So I'll create a new dashboard. I'll select the blank dashboard. And I'm going to go ahead and just throw a chart on here. Make it the shape I want. Select the data source. So I'm going to select the tenant data source. Now by default, it's going to think I want a chart, a bar chart. So I want to switch this now to a map. So click the little chart icon here to the right. It lets you switch the chart type. And if you scroll down, there is a maps option. Select that. Go to formatting, which is this paintbrush looking icon. Go down to the map. Now you could select an out of the box map type here, North America, world countries, but we don't want any of those. We're going to create our own custom. So we're going to click this plus to upload a GeoJSON file. So this is the new map dialog. There's the Upload Geo JSON button. And I'm going to go ahead and select that JSON file that I created just a minute ago from the spreadsheet. Give it a name, click Save. So here's a representation of that skyscraper, 10 polygons stacked on top of each other, the same width, same height. So let me give this a name and save it. And now I need to select what I want to use for the locations in this. So I want to use the floors. And now you can start to see the data showing up in the polygon. And for the color, I want to select what data I want to show in here. So I'm going to select the sum, and I can select the suite square footage. So what this is doing is taking all the suites for each floor, adding all the square footage together, and showing that here on the chart. The darker color, the more square footage it has. The lighter color, the less square footage it has. I could change what I'm showing here. Instead of showing the sum of the square feet, I could show, say, the minimum expiration year, and then this is going to start to show which ones are going to expire first. It's putting a comma in here, but these are actually years, so this is saying 2028, 2026, 2019. So again, looking at all the suites for that floor, it's finding the minimum expiration year. We could also do, say, the sum of the vacant square feet. Again, adding up all the suites that are labeled as vacant together and showing that. So whenever you select, and you can make multiples of these, you could make a filter to change what data you want to show in here. But whenever you're done with it, click Done, and it's now in my dashboard. If you want to preview it, you can click the little eye icon here and preview it and show you what it would look like. You can interact with it a little bit. Okay, great. So that is that example. I'll show you the Salesforce Tower example as well. Let me switch back to my presentation. Okay, so what if we want to do something more complicated than a 10-story building that's completely flat? What if we want to show the Salesforce Tower, 62 stories? There's a feature at the top that's a little triangular. The floors, as you get closer to the top, taper in a bit more. It's not just straight up and down. At the bottom, there's a little notch in the bottom couple floors. So we can show all that as well. Oh, and when you're creating a GeoJSON file for something like this, I highly recommend that you find a good data source. So I found this diagram of the Salesforce Tower. It helped me kind of figure out what the shape of the building needed to look like. All right, so let's come back to our dashboard. And let's put another chart on here. Again, we're going to select the map type. And we're going to upload a custom GeoJSON file again. This time, I'm going to select a different file for the Salesforce Tower. And actually, let me show you what that file looks like really quick. Oh, it's already open. So here's what that GeoJSON file looks like. Sort of similar. The main difference you'll notice here is the coordinates for the top shape are a little bit different, but for the most part, it's very similar to the prior example we were looking at. So let me just go ahead and upload this. And there's that Geo JSON file in Einstein Analytics. I'll give this one another name. And again, I'm going to select the floors. And I could say the sum of these square feet. So I'm actually using the same data set, just in a different custom map created with a different GeoJSON file with different polygons here. Now, there's some things you can do to make this really pop. So let's say we want to make this a dashboard for the Salesforce Tower. Let me remove this other chart. I don't need that one anymore. What we can do is, if we select this default tab, you can select a background image. Down here at the bottom, there's a background image option, and you can select an image file to upload. I have a few different ones to choose from here. I could just kind of pick one. That one's actually a little bit small, but we can make that work. And if I were to preview this, you see the image behind the diagram. But let's make it pop a little bit more, because I don't like this white background behind it. So if we select this chart, click the pencil edit icon, go to the formatting, go to, where was that? Under the map. Just a second, I forgot where this option was. Conditional formatting. I have it in my presentation. Let me switch back to it. Under widget style, we can select the background color, and we can put in transparency. Let me do that. Under the widget style. Oh, I'm sorry. Thank you. Background color. Now I could select one of these colors, but I want to select custom. Now this is any RGB value here, and you can actually make it an RGBA and put in the (0) at the end, and now it's transparent. And there we go. So now we can see through it. And you can still interact with this chart. You could potentially click on it and drive other charts, and so forth. Okay. Let's see how we do. I can do one more demo showing a different building. I can show the Empire State Building. Map. So here is, locations, floor, there we go. So here is the a GeoJSON representation of the Empire State Building. Same idea. The difference here is the top is much more complicated, a lot more points in this polygon here. And I could show you that if you want to see the Geo JSON for it. Before everybody runs off, I just want to make sure that I talk about where you can learn more about this. There is a trail on Trailhead. If you want to create custom maps, definitely the best place to start is to do that. That walks you through that demo, talking about the zip codes in the LA area. So that'll show you how to create that same custom map. All right, any questions from anyone? Yes?
Is there any tool that you can give it AutoCAD kind of chart to convert it into JSON?
Is there a tool to convert AutoCAD into GeoJSON? Maybe, I'm not sure. I haven't tried doing that. Yes?
If you the GeoJSON list give you the warning that you weren't connecting to the last coordinate. If you did connect the coordinate, would Einstein Analytics error out, or would it still accept it?
No, it wouldn't error out in Einstein Analytics. If you complete the polygon, it's still fine. I just typically skip it because if I'm doing anything more complicated than a square, it's just kind of annoying to copy that same coordinate and put it at the end, but you could definitely do it. Yes?
So in all of your examples, there was one floor, solid floor, but like subdividing that by like units.
Have I done one where I divided each floor into units? Not in that exact way. The trouble with showing the units on a two-dimensional diagram is challenging because obviously you might have some units behind other units, so it's not going to look exactly the way it would be. But you could kind of show the relative width of the different the relative size of the different units in there if you wanted to. To do it in a custom map like that, you'd have to actually plot out all the coordinates for the polygon for your GeoJSON in order to do that. One thing you might want to do if you wanted to, like if you're in the real estate industry and you want to show something like a stacking plan, you might want to just use a bar chart to show have it automatically size the different segments in the bar for the size of the square feet for the unit. I would go about it that way. Otherwise, like I said, you'd have to plot out all the coordinates for each suite on each floor. It'd be a lot more work, but you could do it. Yes?
So if you use latitude, longitude, would you be using a geomap?
If you use latitude and longitude, it'd be pretty much the same way. You just put in the coordinates. Instead of XY coordinates, you're just putting in longitude and latitude. The scale for the coordinates can be pretty much anything. You can add negative coordinates. You can have positive coordinates. Einstein will use the coordinates and show you your chart in the way that it makes the most sense. Yes?
Beginning of your presentation, you showed zip codes, and you talked about zip codes a little bit.
Yep.
Is that something that needs to be customized this way as well, or is that kind of
Yeah, if you want to show zip codes on a map, it's not built in, so you would have to have a GeoJSON file. And actually, I can show you what that one looked like for the Trailhead example.
Is it in that Trailhead?
Yeah, you can download it from there. They actually, I think, downloaded that data from, some LA site or state of California site of some kind. But so yeah, if you have a source that can give you a GeoJSON file, then that is awesome because then you don't have to do it yourself. And why can't I grab it? Grab. But all right, it's not cooperating with me. But the file from the Trailhead, it has a lot of extra attributes in it. You don't necessarily need for your custom map in Einstein Analytics, but it doesn't hurt it for them to be in there.
Do you, let's say I was able to find a file that outlined like congressional districts and stuff like that?
Yeah, you can do that too. Yep. Yeah, you could show like voter turnout or how many votes for Democrat, how many Republican, things like that. Definitely. Yep.
So in this case, if you don't want to use like, if you want to split it down by something specialized, so you're not talking about like specific state or you want like territory, let's say, that has different states.
Mm-hmm.
So you assign an ID and use this ID on your table to have the data associated with. So I'll call it like territory A, and then I'll have ID A on my table,
Mm-hmm.
and this is how they synchronize together. And I say that these coordinates for ID A, and there, my ID on my data file is A.
Yeah, you just have to have an identifier that can map to it. So like for zip codes, it'd have the actual zip code as the ID. As long as you have the ID zip code as a column in your data file, then you're fine.
If it's set of zip codes, then I have to give all of them the same ID on my.
You'd just have to have the same ID in both your Geo JSON and your data set. Yep. One last one. Yep. A repository form? Not yet, but maybe I can put them somewhere. All right, thanks everyone.